So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture we are going to solve a problem in which we have to find a subarray whose sum should be equals to 0. Now till now we know that how to find this subarray, right, and its sum, but in today's lecture we are going to see whether the sum is equals to 0 or not. Okay, so let's take one example. In this we have an array. Inside this we have 8, then 4, minus 6, 2, and let's say 6. Okay, now if we see or if we observe this sum of this subarray 4 minus 6 and 2, it leads to 0. Okay, so if this is the case, then we can return true. Okay, I hope you know that what do you mean by subarray. Okay, so subarray is nothing but a part of an array in a continuous order. It can be single element or it can be whole array as well. Okay, let's take one more example. Here array A has 8, 4, 0, 2 and 6. Okay, so here also we can see that the sum of subarray is 0, that is this. Okay, a single element can also be considered as a subarray and this sum is 0 here. Okay, so here also we can return true. I hope you got the question. Okay, now till now we know that how to find the subarray and its sum. Okay, we have solved many problems like this. So if we talk about the brute force approach 1, okay, or we can say at brute force. Now here we can have three nested for loops, right? I hope you know that. So for I is running from 0 to n. Inside this we can have start variable. The value of start is I. Okay, then we have another for loop in which j will be running from I and it will be gone till n. Okay, and in this we have end variable in which the value of end is j. Now we will have another variable, sorry, another for loop in which the k will be running from start and it will be gone till less than equals to end. Okay, so let's say if start is here and end is here. Okay, so the third for loop is going to iterate from start to end, and on the go it will be computing this sum as well. So sum plus equals to a of k. Okay, now that's it. After that we will be going to have if for if sum is equals to 0, simply return true. You don't need to go forward. Okay, now let's say if the execution won't go in this if case, then at last we need to return false. Okay, so if we talk about the time complexity, here we have three for loops, 1, 2 and 3. Okay, and each of them are going approximately to n time, right? So the time complexity will be order of n cube. And if you talk about the space, we didn't take any extra space, that will be constant. Okay, so let's see if the execution won't go here, right? So at last we have to return false. So return false. Okay, I hope you got this. Okay, but we can see that the time complexity is very huge, so we need to optimize this. Okay, so let's come to the approach 2. Okay, now we also seen that how to find the subarray sum by using the prefix sum approach as well. Okay, so let's observe this prefix sum approach. Okay, so let's take this array A. inside this we have 8, then 4, minus 6, 2, and then 6. Okay, now if we try to convert it into a prefix sum array, it will be look like this. I hope you know that what is prefix sum. Okay, the thing is that we need to in this place, this sum till this point will come. In this place, this sum till this point. In this place, this sum till this point. Okay, and so on. Okay, so at first it will be simply 8. Then in this position it will be sum of this and this, right? It will be 12. Then 12 minus 6, it will be 6. Then 6 plus 2, that will be 8, and 8 plus 6, that will be 14. So this is a prefix sum. Now if we observe carefully, see, till this point this sum is 8, right? And if we observe this 8, what this 8 means, it means the sum till this point, right? So here also the sum is 8, and here also the sum is 8, and we can say it is nothing but propagating the sum, right? Now here is also 8, here is also 8. It means that this 8 has been propagated here. So indirectly we can say that this part, or let's say this part, is resulting to sum 0. Okay, so the takeaway from this is, if we got same element, okay, in the prefix sum, it means that the subarray sum is 0. Okay, now let's take one more example because I want to show you something. Let's take one more array. Inside this we have 8, then 4, 0, 2, and 6. Now if we try to convert it into prefix sum, it will be 8, 12, 12, 14, and then 20, right? Now here also we can say that we got two 12s, right? Since the elements are same, so we can return true simple. Here also true. Okay, now let's take one last example. We have 8, 10, 4, minus 12, 2, and 7. Okay, now if we observe, we can see that if we find a sum of this subarray, it is resulting to 0, right? 8 plus 4, 12. 12 minus 12, that will be 0. Now if we try to find a subarray, sorry, if we try to find this prefix sum, it will be looking like this: 8, 12, 0, then 2, and then 9, right? Now here we can see that in this prefix sum there is no elements duplicate, right? So what should we do? Now in these two examples, the elements were not unique, this and this, right? But here we can say every element is unique, but here we got a 0. Now what does 0 means? 0 means from start till this point, this sum of this subarray is leading to 0. So the two takeaways are, if we found duplicates element, or element 0 present, then simply return true. Okay, so we have to search these two criteria in prefix sum, okay, not in the original array. So if you know that how to solve this, then it is a piece of cake. Now finding a 0 in a prefix sum is very simple, right? Just have one for loop in which just start for 0. If it is returning, if we found 0, then simply return true. But how to find a duplicate element? To find a duplicate element in a prefix sum, we need to have two for loops, right? Which will be leading to order of n square. Okay, so this is not very beneficial for us because we need to optimize. Now to optimize this, we need to have some storage. Okay, while we start storing, let's say if we store 8, then we will be storing 12, and when we store 12 again, okay, we will get to know that 12 is already present, so we can simply stop then and there and just return true, right? So this kind of storage, we call it as a hash set. Okay, in this hash set only unique elements are present. Okay, so whenever we are storing an element, okay, and that element is already been stored, then it will simply return true. And if it is returning true, we got our answer. Okay, so to solve this problem, we need to have HashSet here. Okay, but what about this? What about this 0? See, if you talk about this 0, we need to store 0 explicitly from our side. Okay, let's see if we store 0. Now after that we are going to store 8, then 12, and then we need to store 0. Now when we are storing 0, we already know that 0 is present. This will return true. So let's create a prefix sum array first of all. So psum is equals to new int n. Okay, now we are going to have psum of 0 is equals to a of 0. Now we will be going to have for loop in which I will be running from 1 to n. After that we are going to have p sum of I is equals to p sum of I minus 1 plus a of I. I hope you know this, we have solved millions of times. Now let me bring it here. Now creating a prefix sum array is done. Now let's create the hash set. So hash set, inside this integer values are stored. Okay, I'm going with the representation of Java. You can find it out of your own programming language. So new hash set integer. Okay, now here we are going to store the 0 explicitly. Okay, for the first time. Now for here I'm going to use enhanced for loop in which int val a. Okay, one by one the value is going to store in the val. Here I forgot to mention it should be p sum. Okay, now if has set dot contains, if it is containing, then simply return true. So if it is returning true, that means we can go in this if case, so return true, and you don't need to go further, you found our answer. But let's say if the value is not present in the hash set, then at that time we need to store it in the hash set. So hash HSet add val. That's it, we are done. And let's say if the condition is not going in the if case, or the execution is not going in the if case, at last we need to we need to return false. I hope you got it. So with this simple approach we can solve this problem. Now if we talk about the time complexity for this, we can see that we have two for loops, one and the second, and each of them are running for n times. Okay, so n plus n, which will lead to order of n. Okay, now what about space complexity? It is order of n only. Why? Because we have taken the extra space, that is p sum. Okay, and this hash set as well. Okay, n plus n, that will be 2n. Okay, approximately it is order of n only. Okay, this is a time complexity and this is a space complexity. Okay, I hope you got this. If you don't, then I'll recommend you to please try it by yourself as well. So that's it from my side. I'll see you in the next video. Till then, keep practicing. Thank you.